Okay, this is our 184N turbine generator video. It's just kind of a quick overview of it. The main purpose of this was to provide power for all the B pumps or B bus in the plant. A bus was run off-site. So if you lost your off-site power, this turbine generator would take over half of the pump load and provide a safe shutdown. As the General Electric design, it was rated 15.6 megawatts at a half a pound hydrogen pressure. At 30 pounds hydrogen pressure, this generator would be rated at 22 megawatts. You'd have to repower the turbine to do that. It was designed for 55 pounds, steam pressure, 0 degrees superheat, and a 2-inch mercury back pressure. It ran at 13.8 kilovolts and is rated for a 0.85 power factor. The main parts we had up here was the front standard, had the governor, thrust bearings, and your main oil pump, plus your control on it. Up here you had your steam admission valves. Here was the steam turbine. It had 2 stop valves on each side that would feed the high pressure part of the turbine. Then went over here to the low pressure. This would be the low pressure housing, went down to the surface condenser. Had the hydrogen cooled generator. These were the hydrogen coolers. In back they had an exciter. This is a dynamic type exciter, and the Amplidyne that ran that sat on the 3rd floor by the control room. Down below on the 1st floor you had your lube oil reservoir. It'd sit about in here. Had your condensate pumps, lube oil conditioner. These were up by the ceiling underneath the floor, your stop valves. On the lube oil system, you had your aux oil pump. This was for starting up the turbine with and for emergency use. The oil from this went to an eductor that fed the oil up to the main oil pump suction. Once your turbine got up to speed, the oil off your main oil pump went down to the eductor and pushed oil back up the suction to the pump. This unit only had one oil system that ran everything on it. So off your main oil pump, when it was running, it would provide oil to the bearings, went through a cooler and then a reducing valve and put about 25 pounds oil pressure to the bearings. It provided control oil to the stop valves and your governor valve cylinder. It provided oil to the 0 speed switch, which was 2 orifices that were sitting close to a plate with notches, so when the shaft stopped, when the notches would be dumping oil, and you'd have a low pressure so you know your shaft stopped, so the turning gear would start. Turning gear sat back in here. It also provided your thrust bearing wear. Another nozzle would put oil pressure against the nozzle, and as it wore, the pressure would drop. Had more of a clearance between the nozzle and the thrust plate. I'm not sure what this tripped at, it's probably around 18 thousandths. There's a really tight clearance in these turbines. The last thing you want to do is to crash it. The back end was solid, and this had flexible standards that allowed the thing to slide this way for expansion. On the control on it, you had your governor in here, flyball governor, and also automatic control for load control on this. I ran a hydraulic cylinder with a spring on it. This rod would go up. There's the gears on the end of the shaft here, and it'd engage with gears on a shaft, which this would go up and down. This would turn the shaft. Then there are cams on this that would lift up each of these governor control valve rods. There'd be 4 of these. So it's designed so that as this moved, first one set of valves would open, then the other. So you would slowly admit steam to the nozzle block. Full steam flow of the nozzles would be open. You'd have full emission of steam into the nozzle block through the turbine. The front standard, you had your seal steam regulator. It sat in here. I provide steam to the front seals and the turbine seals. At startup, when you're pulling a vacuum on this, you'd have to use sealing steam to seal it. But once you're running, you'd take the excess steam off the high pressure side and it'd feed it back to low pressure. I'm not sure if this was ever self-sealing like some of them, but a lot of the steam from here would be recycled and put back to the low pressure end, and any makeup steam to this was added. From there, you had your exhaust steam would go out to a spray chamber, and then you had a little vacuum pump. So sealing steam would go in, part would go into the low pressure side, and whatever leaked back out would be collected through a spray chamber and then a vacuum pump so you didn't have steam blowing out. You had packing bleed offs on all the governor valves and your stop valves. That all went back there. To start this, you had your load limit. This is where you'd bring the speed up. You had your trip reset lever. There's a trip button down here. You could hit to trip this unit. On the other side of this was the bolt on the shaft that'd come out and hit a plate at high overspeed and dump the oil. And you also had your electric trip solenoid that would dump the pressure to the unit. So to reset it, you'd have to pull this. This ran the speed up for starting it. Had a tachometer. This had several critical speeds. Usually you have critical speeds with your turbine, your generator, and then your exciter. So you had to kind of get through those fast. Once it was up and running, then they take over from the control room and run this. You could sync it online. And then once the plant was ready to start, you'd split it so this ran all the equipment. Big thing was keeping this running the same frequency as the A bus. I know they looked at clocks and they're trying to match the clocks, change speed up and down a little bit so the clocks ran about the same. You had your bearing oil pressure, oil pump pressure. These are valves here for the 2 gauges. You had your stop valve test, emergency governor valve test. These could be open and your valves should go partially closed and open back up again. You had sight flows and temperatures for your main bearing and also your thrust bearing. Thrust bearings are really critical on these because they're running such tight clearances. On your lube oil, you want to keep this oil at least 130 degrees so the water drops out of it. So you had a main standard where your oil returned down there and also the oil piping went inside that. So if there's any leaks, it keeps it all inside the system. Had your auxiliary oil pump for startup. Now you had your vapor extractor. This always kept a slight negative pressure on this. All the oil system keep oil vapor from coming out. You had your DC backup, emergency bearing and seal oil pump. And then you had your aux seal oil pump. We have hydrogen in here. You have to keep your seal oil on this thing at all times. Half a pound is not a whole lot, but it had several different backups to keep the seal oil in. And also if it shuts down, you have to keep bearing oil on this because you got a hot shaft and it can damage the Babbitt bearings. You had a cooler on the outs, 2 oil coolers. One was used at a time for temperature control. Usually once your oil temperature around 115 degrees. You figure about a 30-degree rise in the oil temperature, so it'd be about 150, something coming back in. These were your test panel for running your different pumps for testing. Had lube oil conditioner. It had like water overflow and stuff on it. Had a clean oil tank, a little pump bring the oil back. This had a vapor extractor on it. Your generator hydrogen seals, it was a simpler system. I used the regular lube oil. It'd feed to the seal. Part of the oil would go out with the main bearing oil down to bearing enlargements that had a vapor extractor pump to take any hydrogen off and blow off any oil. The hydrogen would come back with the oil. Then the inside, on the hydrogen side, went down to enlargement. And that was at a float control basically that kept oil in there, and that went back to enlargement too where any vapor was taken off. You had a regulator that maintained the pressure of seal oil above the hydrogen. I'm really not sure what this ran at, but it's probably 5-6 pounds, I'm guessing. But I looked at the pressure of the oil and the hydrogen seal enlargement. compared to the oil going in, and try to maintain the oil going in a little bit higher than the hydrogen pressure. So the big thing on this, that all that oil just went back to your reservoir. I believe it was all like guarded piping, so if you had any leaks, it was all collected back. You had your hydrogen control panel sat down in here somewhere, second floor. And that's where you look at your hydrogen purity, feed and bleed. Outside we had a little shack that had 3 hydrogen cylinders you'd have in service all times, and a couple hydrogen bottles. I believe we used 2, and then you'd swap. And then when they got down lower, it didn't seem like it used a whole lot of hydrogen. Cider housing had brushes in it. Electricians check that. Yeah, this is about all we have on the 184 turbine generator. We do have more information on how it was built and worked if anybody's interested. But that's just kind of a quick overview of B-bus power in 100N plant.